This video is brought to you by PhpStorm. As developers, we have times where we get to process a lot of data. Sometimes it's just a few kilobytes of data, and we don't really need to worry about the performance of our algorithms because computers are so fast. However, when we're looking at gigabytes or more of data, then we need to be aware of the performance of our algorithms, or we might not even be able to complete the process in our lifetime. In this video, we'll discuss the stack data structure and how to use stacks in PHP. Hello developers, and welcome to the PHP Architect channel. If this is your first time here, my name is Scott Keck-Warren, and on this channel, we discuss a wide variety of topics related to the PHP ecosystem. Make sure you subscribe so you can get our latest videos when they're published. Before we go too far into what a stack is, we need to have a small side discussion to discuss data structures. A data structure is a way of organizing data inside of a computer so we can use it effectively. The overarching idea is that we need to be able to take data and use our code to optimize it so we can process it most efficiently. Depending on the data, there are lots of different ways it can be organized, but the same kinds of problems keep coming up over and over again, so we have a basic set of data structures we can use to solve those problems. Each of these data structures has different performance characteristics. We'll use what's known as the big O notation to describe the performance of the data structure with different processes like adding elements, deleting elements, and searching for a specific element as the number of elements gets very large. It can range from big O of 1, indicating it takes the same amount of time regardless of how many elements exist, or big O of n, indicating it increases linearly as the number of elements increases, up to big O of n factorial, which is something we need to strive to prevent, as it will take a long time to process. Now, there are two major types of data structures. The first is a linear data structure, where elements are arranged in a sequence. Examples of this include arrays, lists, stacks, and queues. The second is nonlinear data structures, where a linear structure doesn't work because of operational complexities. Examples include graphs and trees. Stacks are a linear data structure that contain elements that are linked to each other. This is much like a linked list, but with the major difference that stacks operate in a last in, first out, or LIFO method. This means that we can only add elements from one end and remove them from the same end. This makes them ideal for keeping track of items that need to be processed in the reverse order they were found. Because they're linked to each other, we must access data sequentially, and random access is not possible. When we want to insert or delete items into the stack, we do so at the start of the stack. Because we're keeping track of the start of the stack, adding elements is big O of 1. Deleting an element generally is only done at the beginning of the stack as well, so it's also big O of 1. When we're searching for an element in the stack, we need to look at each element in turn. So the worst case will have us run through every element in the stack, so it's big O of n. This isn't horrible, but it's not the best outcome for a search if you're doing lots of searches, and it's best to look up alternative data structures like a tree for this. Depending on your implementation of the stack, your elements are usually pushed to the stack and then popped off. The built-in PHP class, SplStack, is a stack class based on the SPL double-linked list class, which we've discussed in our previous video, so it uses push and pop. Some benefits of stacks are that they do not require contiguous blocks of memory and therefore can help reduce memory fragmentation, and they support effective removal and addition of elements. More about stacks after this word from our sponsor. PhpStorm is a cutting-edge IDE tailored specifically for PHP and web developers. If you haven't used it before, or it's been a while since you last tried it, now's the perfect time to check it out. PhpStorm has recently received significant performance enhancements and has an ever-expanding feature set. Now, I'm a recent convert to PhpStorm and I love it. One of my favorite features is the ability to rename a class and have PhpStorm find all the references and just automatically fix them for us. Curious to see if it's the right fit for you? Head to jetbrains.com/phpstorm to learn more and try it out with a free 30-day trial. Code smarter, not harder. Now, we must stress to never create your own implementation of data structures, as it wastes time that could be used to add helpful features to our software. When I was in a data structures class, we might spend an entire week implementing each data structure, and if we were super lucky, it would work when it was time to turn it in. I can guarantee that someone has already uploaded an implementation of all of these data structures we'll be talking about to GitHub if it isn't already included in PHP. But thankfully, PHP comes with an implementation for stacks in that SplStack class. It provides basic features we need to have inside of our stack without too much extra. If you've watched our video on the SPL double linked list class, a lot of this will be very familiar, as the SPL class is implemented using the SPL double linked list. The most important functions are the push and pop, which will add new elements into the stack and remove the elements respectively. Ideally, we would just push elements into the stack and then remove them when we're ready to work with them. But we may also need to iterate through the elements to see what's in the stack. There are two ways to do this. The first is using a for each loop. The other is using some of the other public functions of the SPL stack. We have the rewind function to reset our iteration to the head of the list, valid to see if we've gone off the end of the list, current to access the current data, and next to go forward through the list. What we really want to do is pop items off as they shouldn't be needed again. That's the whole point of a stack. To do that, we'll use the count function to see if there are still elements in the stack. At the end of this process, the stack will be empty because we popped all of the elements off. Let's work through an example of how we can create a tool to loop through all of the files in a directory structure without using recursion. To start, we'll create a stack and put our search directory into it. For this example, we'll search the Etsy directory. Next, we'll enter into a loop where we loop through until we've checked all of the elements in the stack. I always like to set some kind of a count check to prevent an infinite loop, so we'll add that as well. Now we need to add a check to see if the current path is a directory. If it is, we'll get the contents of that directory and then add it to the stack to be processed next. Finally, we can add our logic to process the file. Because we're using a stack to drive this logic, we're implementing what's known as a depth-first search, because we're working our way down to the lowest level of our search before we work our way back up. The benefit to this solution over recursion is easier to debug, and we could serialize the stack, save it to disk, and then restart it later. As a recap, stacks are a tool for keeping a linear list of items. It has good performance for inserting and deleting, but poor performance for searching. It's useful for reversing a sequence. I hope you enjoyed our video. If so, make sure you subscribe, comment, share, and like, as it does help others find us. Are you using the stack class after watching this video? Let us know in the comments below, or send me a message on Twitter and phpc.social @ScottKeckWarren. We would love to hear how we can help you, and it always brightens my day when I hear from a fan. This is Scott Keck-Warren for the PHP Architect channel signing off, and reminding you to keep watching, keep coding, and keep reading.